Welcome back to our data analytics series. Today, we're diving deep into one of the most influential techniques in machine learning, gradient boosting. Along with it, we'll explore XGBoost, an optimized version of gradient boosting that's known for its speed and efficiency. By the end of this video, you'll understand how these techniques work and how to apply them to real-world data scenarios. Let's get started. We will be looking at the following contents in this video. Gradient boosting is a technique that builds a strong predictive model by sequentially adding weak learners, typically decision trees. Each learner tries to correct the errors of its predecessor, ultimately creating a more accurate model. Boosting is a powerful concept in machine learning. The idea is to take weak learners, models that perform slightly better than random guessing, and combine them in a sequential manner to form a strong learner. Each new model in the sequence focuses on correcting the errors made by the previous models. This approach helps to reduce bias, which is the gap between the model's predictions and the actual outcomes. Let's now break down how gradient boosting works. The process starts with an initial prediction, like taking the average value for a regression task. Then, a weak learner, often a small decision tree, is trained to fit the residuals, which are the differences between the true values and the predictions made by the initial model. This learner's goal is to minimize the residuals, improving the overall prediction. The algorithm continues adding weak learners in a sequential manner, each time refining the model to reduce errors until the performance converges or a set number of iterations is reached. Now, let's talk about XGBoost, short for extreme gradient boosting. XGBoost builds on traditional gradient boosting by introducing several enhancements that make it one of the most popular machine learning algorithms today. It's faster and more efficient, capable of handling large datasets, and it includes features like built-in regularization to prevent overfitting. This makes it particularly useful in data analytics and competitions like Kaggle, where both performance and speed are critical. Though XGBoost is built on the foundation of traditional gradient boosting, there are key differences that make it a more powerful tool. First, XGBoost includes regularization, which helps to prevent overfitting by controlling the complexity of the model. Second, it's much faster due to its parallel processing capabilities, which allow multiple trees to be processed simultaneously. Finally, XGBoost can natively handle missing data, making it easier to use with real-world datasets that are often incomplete or sparse. XGBoost is a versatile tool with applications in a wide range of industries. In finance, it's used for tasks like credit scoring and fraud detection, where accuracy is paramount. In marketing, businesses leverage XGBoost for customer segmentation, identifying different customer groups based on their behavior to create personalized marketing strategies. And in retail, XGBoost helps forecast sales, optimize inventory levels, and streamline the supply chain. You've successfully learned about gradient boosting and XGBoost, two essential tools in the machine learning world. XGBoost, with its efficiency and scalability, has become a go-to model for many data science professionals. In the next video, we'll dive deeper into Excel for data analytics. Don't forget to like, subscribe, comment, and share. See you in the next video.